Okay, so on Tuesday you were given the scenario involved the still a chip skip, but this time you were asked to add the game element to the scenario. So problem solving steps, right? You want to add the game scenario. Now the first thing is to look at what you have and try to understand what is going on, and that also always a good idea to look at what you have there and what are already available. So if you look at what you were given, you would see that based on the scenario, you have a space, a portal, and a chip. Okay, that is already discussed though. And when you run it, all right, when you run it, you know that once you add the ability to propel the chip, it just go on from one portal to another portal already at random. Okay, so here's what you have. Now what you want is the ability to click on the portal and allow you to guess that this is the portal you want before the chip comes out, and then compare the portal that you click with the portal that will be the destination for the chip to see if you make a correct guess, and based on that then you can score. Okay, so that basically was what you were asked to do. Now what else you were given based on this scenario? You also probably noticed that you were given the little initial score of 0. At this point there is no game element being added, so it is also making a whole lot of sense that the initial score here would be 0. Okay, now it's time to look at the code and see what we're given. We'll start now with the three, probably the space, the portal, and the chip. Okay, and each one of these. So let's see. Here's the space. Okay, here's the space. And the space contains only two methods, basically the constructor and the act. All right, and we know what the constructor is supposed to do for any class or any object. In this case, the space represents the world, so we would guess that for the constructor of the world, it is supposed to take care of all the elements in the game, because the world is a container of all the actors in the game. And that is what you actually see here. Okay, you started out with the initial value of the world size, and in this case it's 600 by 400. Okay, 600 width and 400 height, and the cell is 1. Okay, the cell is 1. The cell size is 1 by 1, and in this case we are using an array of portals. Okay, in this case there are a number of ways, we already discussed that. It's just that what you were given here is an array of portal of size 4, and you just simply add each of the file in form of the Greenfoot image to the portal. So you have 4 portals. Okay, each of the portals are associated with the Greenfoot image. Now using this, probably it is now a good time to look at the portal and maybe the chip, but the chip is downstairs right here, to see what the portal is about and what has it given for us. So let's take a look at the portal a little bit before we come back to the space. Here is the portal. In the previous example, we know that for the portal to work, that allow you to let the chip get into one portal and then come out from another portal, you are using the portal link. Okay, so because we use that based on the chip skip example scenario, we keep that. All right, so there's nothing new here. It is all based on the scenario you had already seen. All right. So it is based on that chip skip example where it is making use of the portal link that allow you to go between the two portals available. But in this case, we are working with the 4 portal. But portal link is still there, possibly because you still can use the link to allow one portal to know where to go next. It is just that what you need to be concerned with is that it won't be the static link anymore, right? We talk about this. In this case, for our randomization of the portal, you need to be able to change the portal link. I don't know, probably every time you touch the portal, or at least every step, or at most, not at least. But it won't be static. In the chip skip example, once you assign once you have the portal, because you only have 2 portals, right? Once you get to one portal, it is so obvious that the portal link will have to point to the next portal. 2 portals, static, there's no brainer here. But since we try to randomize the teleporting of the chip, so the portal link right here, unavoidably, it has to be dynamic too. You should be able to set it to be any values when you need it to be. Okay? But it can still remain there. It can still remain there. It's just that you need to be aware that the portal link now will be a little different because it cannot remain static. It must always keep changing. Okay? But otherwise, the rest is pretty much the same. This is the same. Okay? Only different is that in addition to setting the image, you also allow the portal to be associated with a number, so that you can use this number later on to go to the index of the array. Okay, so that's one little trick that you can use. You know the portal has to be identified, so you add the identifying number. This identifying number is called portal location or portal lock. Okay, but it can be anything. You can even say this is the ID of the portal. Fine, because it is the ID of the portal. You use a number, an integer in this case, to identify the portal. It is easier that way. It is easier than you have to compare the string and so on and so forth. Okay? So in addition to the link, we are keeping track as the property of the portal, its identity in the form of the integer value. Okay? And this, we do it explicit that this identity of the portal has to be associated directly with the array and with the direction. Okay, and based on our last discussion, in this case, we're going to go like east to be 0, and then south, east and south to be 1, west to be 2, and then north to be 3. Okay, because based on this, we can do many approaches in calculating the rotating degrees of the chip, right? But if you don't care about doing the formula for rotating degrees of a chip, say for example, you want to use the turn towards, method to do that, then you know that formula becomes unnecessary. So in that case, you don't really have to keep track of the ID in that way, but you may still want to keep track of the ID for comparison later. Okay? So it is a good idea to put the ID as an integer here for later comparison probably. And the constructor, it is used to work with the new operator and to initialize the properties of the object. So initialization goes on with the image. Well, you create a portal, you need to associate it with the image. Here we go. Okay, initialization is with the ID. Yes, you do the ID right here. All right. So in this case, that's it. Okay, the constructor of the portal takes care of initialization of the image for that portal and the ID of the portal. As simple as that. Now, what else? Well, now you need to get portal link. That's remain the same, no change. Okay, so the need to randomly be able to set the portal link to some random values doesn't have impact on this get portal link. Because once you random the portaling, well, once you get it, it's random. Okay, fine, you get random portaling. You just need to get it. And the new one that you need is probably to get the ID. Okay, so in this case, the ID, my variable is called portal location, so you get portal location. And that would be it for the portal. Okay, that would be it for the portal. Now, with that in mind, let's come back and look at the space. So for the space, okay, so we go explicit too for the space that we are going to associate the east with 0, south with 1, west with 2, and north with 3. Okay, and this association right here, okay, will also be linked to the ID that you assign. So it's just by design. Okay, it's just by design. You can, if you want, you can do it differently. Doesn't matter. It's just that in this case, we do it by design like this. Okay, is associated with the ID 0 and the index 0. Okay, south on 1, index 1, west 2, index 2, and north 3, index 3. By design. Your choice. It doesn't really matter that much, especially if you don't plan to use that formula to do the rotation. Okay? And what else? Then it's just the space where you put the image. You should be able to do this already. Okay? What else do you see from the space? You create a new chip. Okay? And then you add the chip. Now the chip is in the middle, so you add the chip. The x and y will be the halfway point on the width and halfway point of the height. Okay? And here's a new stuff that has been added in. Okay? And that is the, look at these two lines. Okay? These two lines, you started out by get the background of the world. So you get the background, the whole background here. So that line allow you to have access to this background. Okay? This is a background. The background is just plain black, starry black. Okay, this starry black background has been used, and then you add 4 portals. So these are added later. This also is added later. Okay, so the background here is just starry black space. So you get the background, you get this starry black space. Okay, and then what did you do? Once you get the background, which is the buffer image type, how do you know that it is a buffer image? Well, you look at this, right? As simple as that one. You look at the Greenfoot documentation, and you said get background is from the world. So look at the world, get background. It returns Greenfoot image. Okay? So we know you get the background, you get the Greenfoot image. Once you have the Greenfoot image, what did you do to it? This was given. Okay? And as I told you, problem solving starts out with the analysis of the problem. You do the analysis, you do it well, you understand the problem. And the first step in doing the analysis is look at what you were given. Try to understand it. Don't panic. Don't imagine. Don't mano. Come on, okay? This is the thing that you have to set root in reality and look at the instruction, look at what you were given, okay? You don't just like imagine everything and dream and never know what exactly was given to you. All right? So in this case, this is also what given to you. You get the background image and then you draw image. Okay? So do you know how you draw image? Well, you consult the Greenfoot here again, and where was I? Let's close it. I know. Here you have Greenfoot image. You go there, you say on Greenfoot image. Once you have it, there are a number of things you can do. You can draw image, you can draw line, blah blah blah. So many things. Okay, just by get background, it allows you to get Greenfoot image. And once you have the Greenfoot image, the example showed that you can draw the image. And what is the image you draw? It is the image of the new Greenfoot image. This new Greenfoot image, okay, has been built. This, how you know how it works? You look at the constructor of the Greenfoot image. And the constructor of the Greenfoot image look like this. There are 5 ways to use the constructor of the Greenfoot image. Okay? And in this case, you want to draw a string. Okay, you want to draw a string. Or at least you can guess that whatever you draw will appear here. Okay? So in this case, it's just the example. The sample code told you that, hey, you use this, you get this. So that you don't have to dream about using the scoreboard, you have to dream about, I don't know what to do. Okay? Because it was given to you here. And you can work your way up from here. You don't have to start from zero, knowing nothing, because actually you know something. You just don't know that you know. That's it worse, right? When you know, you're supposed to know that is something given to you, and you don't know that is what you know, you don't really know. You got confused, right? Fine. Good. Okay? So, you know that this is given to you, and the result of running it will look something like this. So study it. Study it. Why the 2 lines of code result in this? Why the 2 lines of code result in this? And how did you use it? You started out by get the background, draw the image, and the image just appear here. Okay? Panic wouldn't help you. Okay, so here we go. You know that once you get a Greenfoot image, you can draw another image on it. And that is what it did here. Get the Greenfoot image, the starry background. And then you draw another image on it. And the image that you draw happen to be a string image. Okay? And you get the string image by providing the string. In this case, the string is score 0. And then you add the other attributes of this image. For example, this string image supposed to be in orange, okay, on the foreground, with the white background, with the outline color of black, and it should appear at 0, 0, which is the upper left corner. Okay, which is upper left corner of what? Of the background image. Of the background image. Okay? And what is, well, I don't know, what should be of your interest is that you doing this on the image. Whatever you've done before, don't forget you add various things into the world. Okay? You grab only the background, modified it, and everything else remain the same. Okay? Before you get to those 2 lines, you don't have this. You only have the background. You only have this in the middle. This is what you have. Okay? Before you get to those 2 lines, you don't have this yet. You have the background. You have the 4 portals. You have the spaceship, right? And then you just grab the background, only the background. You never touch any of the portal and the spaceship. You just grab the background out, add that, and then put it back in. Did it affect any of this portal and the ship? No. The modification process happened on the background, and everything else remained the same. And that will help you a lot. When you update this, you will also realize that the updating of the image right here doesn't affect any of the images. Any of the images you pre-included into the space. You update this, fine, it is updated. The rest remain the same. Okay? And that is the space logic. Okay? And the purpose of this space logic right here, especially in the constructor, is that it introduces you with these two lines, which you will eventually use. Well, if you follow this, if you don't use any, well, there's another way to do it, but if you follow this approach, then you will use these two lines too when you try to update the score. All you need to do is just change the text right here. Okay, change the text to what? To something like score, and then instead of 0, you get the score, for example, and then the score will change depending on what the score right now. Okay, so whatever you need, you just need to do the calculation of the score, and then provide a method to get the score, and then you get the score, and then copy these two lines. Okay, and then there we are. You are supposed to have the score updated based on your calculation. And then the ACT method. We all know that the ACT method of all the classes in the game, in the scenario, will always be called during each iteration. Each of the actors' ACT and the world's ACT method could be treated for different purposes. Okay? So the first thing that you probably need to think about is whether or not you would need the ACT method for that class. We need the ACT method in the chip class because it must determine the portal. Okay, so you have the check portal method in the chip class, and it has to be checked in every iteration. So that makes a whole lot of sense. What about the world, the space? In this case, why should you want to use the ACT method for the space or the world class? Well, it doesn't have to, okay? But one of the places that you can do the randomization of the portal link is in the world class. You can allow the portal itself to do the randomization. That would even be better. So in that case, you might also add to the ACT method of the portal so that each iteration, the portal will random the portal link into some of the 0, 1, 2, 3 values. Okay? Or you can use the world to do the overall controller in this case, and then assign the random portal to the random link to the portal link every time. Okay? So the one shown here allow the world to do that. Okay? So in each of the every ACT method, it will iterate into each of the portal and then assign a new value to the portal link of each portal, so that the portal link will be randomized in each iteration, every iteration. Okay, there are two places that this might work, in the world and in the portal itself. You can do in the ACT method of portal, and each one will be responsible for randomizing its portal link, and that is even better. Okay. Now, Then the remaining challenge probably will be in the chip class. And the chip class here was what was given? Well, it was given with the ACT method that allowed the chip to move and allow it to check the portal. Okay, the move class hasn't changed, so it remains the same. So I won't even go into details about it yet. The check portal also very close to the one in the example, but only that this allows the portal to be moved at random. Okay, so the chip gets to the portal, it comes out to another portal, and in this case, it's making use of turn towards. Okay, so in case you want to know how it is used, in this case, you look at the logic. It says what? It says if it is not yet teleported and you happen to be able to find a portal object, okay, then you are doing. What about these two lines? What are they for? You make the chip disappear. Okay, once the chip touches the portal, you know that it has to disappear before it comes out from the other portal. Okay, these two lines are the trick to make the chip disappear. The actual one is this one. Okay, you set the new image for the chip to be Greenfoot image of 1 by 1 pixel, and 1 by 1 pixel is so small you wouldn't be able to see. But you also want to be able to set the chip image back later. So that is the reason why you start by get the image first. This is the chip image. You put that in a temporary variable image, okay, and then change the chip image to a 1 by 1 pixel. After you decide on the portal, you set the chip image back. Okay, when at the time you set the chip image back, the chip will look like it is coming out from the other portal. Okay, and this work given to you. If you don't panic, you study it, you should be able to learn something about it. Okay, so the first two lines here, you set the chip image to a 1 by 1 pixel, make it disappear. All right. At the same time, you store the chip image to be used later, and then you get the portal. You get the portal. You decide on what portal you are touching. Okay. So you get the portal. Now at this point, oh, okay, I see. You should be able to get the portal from here so that you don't have to check that. But anyway, okay, you get the portal one more time. That could be a little bug. The best way is you should get the portal from outside the if right here and use that to be like portal. A better way yet, maybe it should be something like this. Better yet, you should do something like this from here. Because now you are doing a redundant statement that should be avoided. You should do that there, and then you should do it here. Yeah. One object at offset. Okay. Let's see. It doesn't have to be a duplicate. You do this. if not teleported and portal is not null. Okay, let's see if it still works. Now, run. If it doesn't crash, it will work, right? And that could also be written off because you don't have to worry about that one. There we are. Even simpler, okay, you can make a little fixes and things go fine. Alright, so this redundancy allows you to remove the another null portal check right here. Okay, so make the code even simpler to work with. Anyway, alright, so you said if you can do okay, so you say if not yet teleported and the portal is not null, that means you found one object at the offset 0, 0. Okay, if you do this are all true, that means what? That means you are at or you are touching the portal. You are ready to teleport. Okay, you are not yet teleported and you are at the portal. That is when you started out by getting the Greenfoot image, doing these two lines, right? Greenfoot image, set the chip image to 1 by 1 pixel, and then in this case increment the delay count, the teleport delay count by 1. Okay, increment the teleport delay count by 1, set the new location of the chip into what? Into the x and y coordinate of a new portal. And how do you know to get to the x and y, the new x and y coordinate of the teleported portal? Well, you get to the portal link. All right, you go portal, get portal link, and then get x. Portal, get portal link, get y. That will give you the x and y coordinate of the portal to be teleported to. Okay, so you set the new location for the chip to be the x and y coordinate of the new portal. And once that is done, you make sure that the chip would turn toward the center of the universe, of the space. By doing turn towards w over 2 and h over 2, w is the height, the width, and h is the height. Okay, and if this is done, then TD is supposed to be reset to 0. So TD++ here should be set somewhere. Okay, the code here is kind of messed up a little bit because it has been taken from the solution. But anyway, okay, you use the teleport delay by incrementing it to decide what to do about it. And in this case, when you set the location or it is found, you're supposed to set the teleport delay back to 0. Okay, you're supposed to set the teleport delay back to 0. Now, these two, okay, these two in this particular example, you might not really need them. All right, but they are given to you anyway because you're going to need them later. Okay, and then because you are now found the portal to be teleport to, you set teleported to true. Okay, and then set the chip image back. Okay, so this part, when you are touching the portal, that's what you do. You turn the chip into a 1 by 1 pixel so that it look disappear. and then you put the new location of the chip into the at the new portal. Okay, turn the chip toward the center, and then now set teleported true and set the image of the chip again. And now with teleported true, okay, with teleported true, you are going to be at this point, and you check if teleported is true, and you intersect. You do not yet intersect the portal. Okay, now you set teleported false. Okay, and that is what was given to you. You really don't need to touch any of this here, okay, because it is taken care of the part where you already set the teleported to true. All right, that was what given. Now you were asked to do what? You were asked to do the, I don't remember what else you were asked to do. You were asked to detect a mouse click on the selected port, okay? And then you were asked to do the required logic on guessing for guessing and scoring and ending the game, and calculate the updated score. So mouse click, where should you want to detect the mouse click? In which classes? In which class? You have 3 classes. Since the mouse click will be on portal, okay, among the 3 classes, you should not think about the chip. There are actually 2 other classes. There are actually 2 classes that can see the portal. One is the portal itself. The other one is the space. Okay, if you allow the space to check for the mouse click, then you're going to need to use that one. Mouse click now, and then check whether the click is on the portal. Okay, you can do that by using mouse info, get the actor, and then based on the actor, you can check the instance of the actor. All right, if the instance, you use instance of. Okay, if the instance of the actor is the portal, easy. You get that portal and find the location of the portal by calling get portal location. Okay, and that way you know exactly what the portal is supposed to be. Right? So let's look at the alternative. Remember, when you work with this, always think about the alternative, because it's allow you to decide which one would be better for you. All right. So among 3 classes, which are chip, portal, and space. Okay. Only portal and space will be a good choice at seeing the mouse click on the portal. If you decided to use space for this purpose, okay, so whenever you have a mouse click, space has to know it. It will look something like you're going to need to do like green foot dot mouse click, and then since this is in the space, it has to be now, and then you use mouse info dot, I think, get actor. Okay, portal dot class. Oops, let's see, I forgot. It's over here. You use mouse info, and mouse info you get actor, just return actor. Okay, so you use get mouse info get actor, and then you use this instance of, and then portal. Okay, to check whether or not it is a portal. If it is a portal, then well, you actually find the mouse click there. Okay, or if you decide to use the portal for this purpose, then it's we go something like probably in the act method of the portal, or one of the method you do the mouse click check. But since it is the portal, you use this. Okay, and now if it is a mouse click, then because it happens on the portal must log the mouse click to be used later. So if the above is true, then you log the value. Okay, then the portal log the mouse click value to be used later. Okay, so among all four, there's supposed to be only one click though. Okay, and when that is the case, then later on when you check on that particular value, you would know that, oh, okay, that one has been clicked, and now I should respond to that one. Okay, so those are alternatives. You have two places where you can check for the portal, and either one should work fine. Okay, either one should work fine. So here, if you use that one in the portal, you might define a method something like public in click portal. Okay, and then you do if greenfoot dot mouse clicked this, because it is in, let's put it there, in portal.java. Alright, so this one is in portal.java. This, then you might do something like return portal location. Okay, otherwise return something that is not known by anyone, say -1. Alright, because if you are expecting the portal location, it cannot be -1. Okay, so you turn something that is unexpected. So every time there's a click on the portal, you will just return the portal location. In this case, it will be 0, 1, 2, or 3. Okay, and the rest will be returning what? A -1. So if you do this when you want to call the click portal, well, you will call it in a chip, right? Because once the chip touches the portal, it then will try to figure out if there's a click on the portal. So it will have to run through all the 4 portals and call click portal. Okay, call click portal. But that is pretty easy to do, because you can get world and then get all the portal objects. Right? You get world and get all the portals object, and for all the portal objects, 4 of them, you can use for each loop to run into it to see which one has been clicked. And it will look something like this, okay? Say in chip.java, all right? To check which portal has been clicked, you may do this. One, you call get world, okay, and then get all the portal objects from the world. And then once you call get world and are able to get all the portal objects from the world, what else you can do? You use for each loop or for loop, okay, doesn't matter. For each loop to go over all portal objects and determine which one is or was clicked. All right, the line here you could do something like, let me see. Okay, you can do like, for example, let's assume you define a variable called hash guess, okay, and this hash guess initially is -1. So when it is -1, there's no guess. If it is 0, then you guess portal 0, which is what? The is, okay? If it is, what is that? It should be based on the ID and the index of the how you define anyway, okay? So let's say if you define hash guess as -1, where there is no guess or no click on the portal, okay? You can do this. First one, you have list portal. You have to import that first, right? Portals equals get world. That's how you get the world, right? And then once you get the world, you want to make sure that before you call, okay, let's try call this, and you want to get objects of portal class. Okay, get world, get objects, portal class. All right, so now you're going to have all the portal objects from the world, right? Once you have that, what do you do? Once you have that, what do you do? You can do for each portal P in portals. Okay, for each portal P in portal, hash guess equals hash guess click portal. As simple as that one. Okay, this one line. After you go through this one line, hash guess will have the value of the portal that has been clicked. Anyone can tell how it works? Let me move this down for ease of understanding. Remember, if you can do it without using the if statement, that would be better. Okay, if statement always take longer time to process than the multiplication and division. So if you can go through it with the multiplication without touching the use of the if statement at all, that's great. Do it. So, anyone? How would this happen after you run through the 3 lines right here? You will be able to determine the port number, the portal number that has been clicked. And if there's no click, then has guess will remain unclicked, no guess. Remain the same, -1. How does it work? But honestly, I haven't tested it whether or not it is possible to do more than 1 click per iteration. Okay, if you can do like 2 click on the portals on 1 iteration, this wouldn't work. But I haven't tried that. It has to be quick enough to do it. So you started out assuming that the guess is -1, which you don't have any guess on the portal click, right? And then you get all the portals. Once you get all the portals, if your assumption is correct that for each iteration there's only enough time to click 1 portal, no more than that. Okay, that is one very important assumption there. Okay, so if an iteration just allow you to have enough time to click 1 portal, then that meant what? That meant in any iteration, there is only 2 possibilities. One, there's no portal click. That meant a call for click portal will always return -1. Okay? All portals. And 2, another possibility is there's no 1 click. That meant 3 portals will return -1 and 1 portal will return its portal value. Right? So you started out with guess of -1. There is 1 click, then the other 3 is going to be -1. So you're going to do 4 multiplication of -1, that's return a 1. So you're going to have 1 multiplied by the portal location. But if there's no portal click, then you're going to have 4 -1. With that -1, you're going to have 5 -1. It will be -1 as a result. Okay? So using this chunk of code, you would be able to get what portal has been clicked. And then if you put that next to the code in the chip class where it touches on the portal and decide on where to go, right? You will be able to get the next portal to go, the guess portal, the actual portal compared. You can now know whether or not the guess is correct. We okay with this one? So, here's one of the possible game logic. And the game logic here, because, in this case, we're going to use it in a chip. The chip will know where to go next, okay? And then if you use this code also in the chip.java, then you also will know what the click is on. You can do the comparison. So the game logic will probably look something like this. One of the approaches anyway. So in the chip.java, and now here for the game logic. Okay, so also in check portal. Okay, we saw check portal already, and it is called here in the app method. Okay, and check portal is that part where you allow the chip to teleport it, and now we're going to put the game logic in here as well, because at the time where the chip teleport, it knows where to go. Okay, so when it knows where to go, it is a right place to also get to know what has been clicked on the portal. So now it knows where to go, it knows what portal has been clicked, it provides the comparison, and so you know that whether or not the chip or the guess is correct or not. Okay, so it's going to be in here in the check portal method. All right, and the logic could go something like this. When a chip hit a portal or touch a portal, in other words, i.e. portal is not null. Alright? You do change the chip image to 1 by 1 pixel image. And then you might want to increment the teleport delay, which what we do is TD by 1. Or maybe TD plus plus, okay, by 1. And now this is the point where you initialize has guess to -1. That one, okay, could be initialized here. And now, once you initialize has guess to -1, it should follow by these two statements there. So it will follow by then visit all portals to find out which was clicked. Okay, and then if, and that would be these two parts right here to find out which one was clicked. And then now another if. This if right here goes like if there is a guess and TD not yet max. Okay, remember we do TD as the teleport delay. Okay, in our case, the teleport delay starts from 0 and increment in each iteration. It's up to you to set the max teleport delay. It could be 50, it could be 100, up to you. But it should only count before it gets to the maximum teleport delay. Before that, if it reaches the maximum teleport delay, that means what? That means your guess is no longer valid. Okay? So the logic to check that would be something like, if there's a guess and it's not yet the maximum teleport delay, or there is no guess, okay, and TD is max. So if there's a guess and not yet maximum teleport delay, or there's no guess but it is a maximum teleport delay, okay, if that happens, you do what? You do set the chip location to new portal at random. Okay, so either way, you're gonna set the chip location to a new portal at random, and then after you set the location, you rotate the chip to center, and now you're ready to verify the chip. Now ready to verify the guess, and to do that, you just go like, if guess is same as random portal, okay, when that is the case, you just increment the correct guess count by 1, right, because it's correct, and then you compute the and update the score. It is at this point, and then if it is already a correct guess, right, you reset the guess value, which is what? Has guess, to -1. You are now ready to guess again. Alright, and that is if you have the guess at the same random portal, which is a correct guess. Okay, but don't forget that this if statement allows 2 to come in. Correct guess, no guess, but max out. So this one will work for this condition right here, but you have to take out that one, and that would be here. Else, this one, if guess count is max, okay, no guess, all right, no guess, so we didn't check that, but if it's max out, you do what? If it is max out, you draw the game over message, okay, because it's max out. But otherwise, if it is not max out, that meant what? That meant you have the guess, but the guess is not correct. Okay, this you have a guess and it is correct. You do this. Okay, if it is not yet max out, that meant what? That means you have a guess, but it is not correct. Okay, and then you do what? That meant you are ready to continue playing. So when that is the case, you do this. You reset the teleport delay to 0. Right? Because, well, you guess but it's wrong. So now you are ready to play again. A teleport delay should be reset to 0. So you start counting again. Okay? And also you need to set teleported to true. Okay, that part is so that you can move on and allow the teleport to be reset to false later. And you're gonna have to do this. Change the chip image. well, get the chip image back. Okay, so at this point, you allow the chip to reappear and continue to fly. Okay, so at this point, the chip image is still a 1 by 1 pixel, so everything is gone. All right, at this point, that point, so it's only at this point where you are ready to play again. You can now set the chip image back. And that's about it for the main game logic. Okay, and the rest, there are a few things that you might be interested in. Say, for example, you have to compute and update the score. Okay, so that's two things. You compute and you update. All right, compute and update. And to compute the score. Okay, to compute the score, you can do this in the chip.java. You might do something like, in my case where I worked, I just go like this, public int get score, and then I just do current score plus equal. I define a constant max TD. Okay. You can do like correct guess is 1. Okay. Or in my example, I set maximum TD to be like 100. Okay. So if you get the correct guess quickly, then the score is more. It will be like, let's say you get the correct guess at 10, the score is 90, because that giving you the bonus point for being quick to make a guess. So if you are slow and you get the correct guess at almost 100, the score will be like 1 or 0. Okay, so in that way you get a dynamic way of calculating the score based on how fast you can click to get the correct guess. Alright, and there you get the score, you do this, and then you want to update, just call, and well, it will be used at this point. You compute right here, and then you update. To update is easy, right? Because you saw the example right from the code. So to update the score, also in chip.java, you could do something like public void draw score. That is what you want to update. Okay, and remember this code, greenfoot image, get the background, right? And then you said get world dot get background. Okay, and remember that you do bg draw image, and now you said new greenfoot image. Here you need a new line. Okay, it's going to be something like score and then get score. Alright, and then you do something like a little space there, and then the rest is pretty much the same. You use the font is 24, the font size, and in addition to font size, you do color, orange, and white background, And what else? I think the outline is black. Okay, and at location 00. And that's it. Okay, almost exactly the same as the code given. The only difference will be now you call get score to provide this new score update. Get world. So for those of you who haven't finished it, or try to finish but or just finish it without knowing how you did it, okay? Go back home and try to work this out. I'll post the solution sometime next week, but this should be like additional information that you could use to try to finish it. I want you to try it on your own first, so you know what you know and what you don't know. And that is important, to know what you know and to know what you don't, so that you can spend time on those that you don't know and get yourself to know them. Okay, I'll post this thing pretty much. Okay, similar to this thing. I'll post it sometime next week. Any question about this? Most of this, what we discussed, this straightforward. Okay, this is straightforward. You've been given the example code already. All you need to just copy and paste and make sure that instead of using score equals 0, you do the calculation of the score and put it there as the updated version of it. Okay, the only challenge I can see, I guess, would be the logic on to do the game over here. Okay, but it's not overly complicated. I don't think so. And say here, if guess is same as random portal, you get the guess here from there, right? You visit all portal file which was clicked and use that to check as the condition right here. Any question so far? So for the next 30 minutes or so, I would like to draw your attention to the Greenfoot website a little bit. Oh, what have I done? Okay, and from the Greenfoot website, if you go to, you enter the Greenfoot website, and you go to documentation. Okay, there's the part right here for going further, and what I want you to look at is the dynamic helper classes. Okay, so from here we're going to go through some videos, all right, and later on we're going to work on some of the projects that allow you to use these dynamic classes. It will be useful for your project too. Okay, so let's start out with this. That should take about 30 minutes, several videos. All right.
This tutorial is an introduction for Dynamic Classes series in Greenfoot. We will show you today how we can use these classes to make our scenarios more dynamic, so how we can use real-time weather information in different cities in the world, or to get image from Google Maps to make our games or simulation more dynamic. And in coming videos, I'll detail how you can program this. Let's start. When you open Greenfoot, it will ask you to create or open a new scenario. So we'll go to scenario, click new, then we'll write anything. Let's say test 1, create. When you do this, a new window will open with only abstract classes. Now we will show you how you can use dynamic classes in new scenario by pressing edit menu, import class, then a new dialog will open with all helper classes available in Greenfoot. We are interested in the map and weather classes. The map class, if you click on it and see the documentation, it has two constructors, one with location only and one with location and width, height and zoom. This class enables you to bring a Google Maps image for a specific location. You can notice that the location can be a country name or longitude, latitude, or even if you have, for example, postcode in UK and USA and other countries, or even you can decide the village name, big city name, or even shop name, then the country. It has a couple of methods: get image or set type if you want to change the type map to road map, satellite, hybrid or terrain, and set zoom and zoom in, zoom out to enable you get different levels of Google Maps. The other class is the weather class, which you have to decide the city and country names, or you just you can call the other constructor, which is without any parameters and will retain the status of the weather in your local place. This class provides many methods, which get city, get country, and get humidity, get pressure, get temperature in Celsius, and get wind direction and get speed. Let's see how these classes can be useful in our scenarios. Now let's see some use cases. I'll open Greenfoot and then open the ant scenario, but this ant scenario is different from the classic one, that the image is taken from real Google Map image for a desert, and you can change the location of this scenario just from one line code. I also can run simulation, points simulation, with different Google Map image. So this one is a terrain, this one is a satellite image. So you can see now how the birds will fly around these trees. I can push the image up to the north or to the east just by one line code. These simulations are not the only case I can use Google Maps. Use them also in games. In this Canon catch-up shooting game, I'll shoot on land and water, and you notice that automatically the blob will notice if it's water it will sink, but if it's land it will splat. So when it hit France or Germany or Denmark, for example, Ireland, it will splat. More than that, I can have games which not only recognize water as land, but also depend on weather information in different cities, in different locations, to move boats. So if I run now, you'll notice that this boat is faster than this one, and this is because the wind speed in different cities are controlling the different boats. So if I run this game tomorrow, maybe this one will be faster, and we will see how we can control these boats to which one of them to raise them, so which one of them will anchor first, and how you can write immediately in the Greenfoot world. I hope that you find today's tutorial useful. I'll detail each scenario how you can implement it in a separate video. Thank you very much.
Here's the first example. Okay, this one.
Hello everyone, I'm Amjad Al-Tadmuri from Greenfoot Blue Jay team, University of Kent, UK. Today is the first tutorial after the introduction about Greenfoot dynamic classes. At the end of today's tutorial, you will be able to use Google Maps images in your scenarios, such as this birds simulation scenario or this ants searching for food scenario. So to start, we will open Greenfoot, then we will go to scenario, open, and I'm going to use the points simulation scenario, which is in the box scenarios. After opening the project, we have to compile, and we can notice that the background is just one color, which is green, and we want to make this scenario more realistic, so we want to change this picture to a real image taken from Google Map. So first of all, we have to go to edit menu, then import the map helper class. After pressing import, you will notice that it became here. Now I have to go to sky world class. These two lines are responsible for drawing this background. So after I remove them and recompile again, I'll find that the background became white. So what we have to do is to write here the new background. First of all, let's create an object of map. Let's call it map as well. So new map. The parameters that I have to pass is firstly the location. So if we try to put the location as Africa, the width and height the same as the world width and height, and the zoom level is 8. Then we have to say set background, then pass the map.getImage. So after constructing the map object, get the image from it and put it as the background for this scenario. If we compile, Google Road Map image became as the background and the trees are randomly drawn above it. We can notice that the image is smaller than the word. For that, the green foot is repeated. So what we have to do now is to reduce the size, and if you read the manual of Google Maps, you'll find the maximum size is 640 times 640. To keep it rectangle, I'll say 640 times 500. Compile again, it's better now. We can notice that the background is a road map, which is not suitable. So let's change the type of the map here between creating the object and setting the background to a terrain image. So if we compile now, you notice the difference between the road map and terrain. Another notice that the image contains two lakes here and here, and the trees in this scenario are drawn randomly. So maybe if I press reset, the trees will be drawn above water, which is not realistic. So what we want here is to go north a little bit and east a little bit, but because the location is Africa, we cannot do much. So what I did, I googled the longitude and latitude of Africa and found that if I put these coordinates, I'll almost get the same image. So you see the same two lakes here, and as we said, we want to go north and east, so we have to change this one a little bit. Let's reduce it to 3 and this increase it to 8 to go north and east, and the scenario became more reasonable. We can run it now to see the result. Again, if you don't like terrain, you may use satellite image. So set type, satellite, compile. It will be like this. So in summary, today we introduced how to use Google Maps in our classes and what are the parameters that we have to pass for this class and how to change the type of the map that we are using. In the next tutorial, we are going to talk how we will use image from Google Maps as an actor rather than as a background of the word class. So if I run now, you see how the focus going into the University of Kent, or also how we can from here rather than from the code, how we can change the type to, for example, road map or satellite, and how to zoom out, zoom in from here. I hope that you found today's tutorial useful. Thank you very much. Hello everyone, I'm Amjad Al-Tadmuri and welcome to today's tutorial about map class in Greenfoot. We will see today some details about the methods that this class provide and how we can make actors using this class. So if I start Greenfoot, now I'll go to scenarios and create a new one. Let's call it maps. Create. Now I'll have an empty scenario which contains only the word and actor classes. I'm going to create a new world class and just create a world class which is an empty one without any image. Let's call it background. And I want to create an actor which uses Google Maps, so I have to go to edit, import class, then select map from here. Import. Now if you open the documentation of map class, you will find that it contains two constructors. One takes only location as a string, the other takes location, width and height, and zoom. I can change through set type the type of the map as road map, satellite, hybrid, and terrain. I can also select the zoom that I want, or zoom in, zoom out. The zoom factor is between 0 and 20. Now if I create an actor, let's call it university, okay, and within the code in the constructor I'll say map object, then new map, Let's put the postcode of the School of Computing in University of Kent, which is CT27NF. Now I created an object of map. To use it, I have to say set image, which is the method of the actor, which assign an image for this actor, then get the image from the map object. Close it, and now when I compile, I can use this actor in my scenario. So you can see it's a map, and if I run, nothing will happen, and if I press right click, I'll find only the methods from actor class and act. You can see that the center is in Kent, but it's zoomed only 5. The default factor is 5. If I want in running time to do something, and if I want to add functions here, I have to open the code. In act here, I'll say map dot set zoom. Before that, I have to move map object to the class level. So here map, then I can say map dot zoom in and pass 1. So each step it will zoom in, and don't forget always you have to set the image, which is the image taking from the map. So I'm updating the map here, but it will not reflect until I again set it to the actor. So if I compile now, create an object. Before I run, I'll reduce the speed a little bit. So let's go run. See, it's each step it will zoom into England, then specifically Kent, Canterbury, then the university, then the building that we are in now. Now, if I want the users to be able to zoom out, zoom in, or to change the type of the map, I have to open the code again and create suitable methods. Public zoom in, no need to parameters. I can just every time zoom in once, then set image. I can also put zoom out, and set type. Set type. For set type, I have to pass the type as a string type. Here, map dot set type, and the string is type. Again, set image and pass image map dot get image. Now if I compile, no errors. Create a new object, put it here. The speed is good. Run. See how it's zooming in. If I right click set type, I can change the type to, for example, hybrid. Then okay, it will change. Again, if I run it, it will zoom in to the university. I can zoom in from here as well, or zoom out. I hope that you found today's tutorial useful, and in next tutorial we will talk about how to use maps in games. For example, I can run this game, and every time I shoot on land it will splat. Every time I'm shooting the blob on the water it will sink. Thank you very much.
Okay, and the next one is show you a little trick on how you can detect the land and water, which could be useful for some of the scenario you're working on.
Hello everyone, and welcome to this tutorial from University of Kent Greenfoot team. This tutorial today will explain how we can make the Canon catch-up game more interesting by replacing the background from just white or any background to a map, and also we want to recognize the land versus water. So when it's a water it will sink, but when it's land it will splat. So I'm just showing you now the original game and how the blob will splat. Now what we need to do is to put the background map. So first of all we have to go to import class and use the helper class map in our scenario. Now I have to go to my word and change the background to use the map class, and let's create an object of any place on Earth, let's say London. Now I have to say, as usual, set background, then give it the map.getImage. Now you can see, if I compile, that the background became Google Map, which centered at London, and if I run and shoot Germany or France or even the water, the blob will splat. What I need to do is to change this behavior, and for that I'll create a new method called isWater. This method will detect if a specific pixel is on water or on land. So isWater, taking a location which is xy, then we'll take the color from the image.color at xy, and if the color get blue more than the color get red, and the blue more than the green as well, that means this point is blue. Otherwise it may be green, red, or gray, any other color. So you notice that color class is in the AWT, so I have to say java.awt.color. I have to import this class. Now I'm saying image. What is this image? The image is actually taken from Google Map itself. So I have to say the map.getImage. I have to put it in a separate object. I'll say greenfoot image equal to map.getImage, and I'll pass the set background as well. Now it's an object, but I cannot use it because it's not on the level of the class in this method, so I have to take it outside. I have to say greenfoot image here, then initialize it in the constructor. Now I can compile and everything's fine. The world will recognize if it's water or not, but I have to change the behavior of the splat of the blob to make use of this. So what I have to say, you notice that in splat it will play a sound, splat sound, and add the splat object exactly the blob location and remove the blob. So I have to remove the blob always, but these two lines will be conditioned. So I have to put the condition here. If getWorld will give me the abstract world class, which doesn't contain isWater, so I have to cast it to my world. So my world getWorld is water, and pass the location of the blob now, get x and get y. Now if it's not water, what I have to say, add the splat object and play the sound. Otherwise don't do it, and on all cases remove the object. Compile. Now if I took the cannon here and run, shoot on land, it will splat. On water it will sink without any sound as well. In the next tutorial we will see how we can make use of real weather information in different cities in the world. So if I run this game, I'll see that this boat is much faster than this one, because each one of them is running according to the wind speed in different city. So if I run this game tomorrow, maybe the blue one will be faster than the brown one. I hope that you found this tutorial useful. Thank you very much.
Okay, so that is something I hope you would find some time and look at and spend some time with. It could be useful for your project. Okay, so you know where to find this, and whatever we show in class today should be adequate for you to get started and hone yourself some skill that you needed for doing some more exciting game design. The rest of the class, we have a little more than 1 hour. I want to do some problem solving again. Okay, and this time we're gonna work on this one. Okay, so it's now time to spread out and form the group. So it's good for any of you who are falling asleep right now to wake him up and just spread out from the groups. We're going to work on this as the group again. Okay, spread out from the group. Get the flipboard, anything that you might need to do this problem solving. Okay, from the groups, we'll talk about this after you have the group, but just like this is the hors d'oeuvre, okay? So you know what you'll be working with the rest of the class today. Okay, I want each group to look at the game here, the simulation here, okay? And your objective for today problem solving is to try to figure out the approach that you might want to take in order to replicate this scenario, okay? And in order to do that, same thing that you need to take is, number one, you have to analyze the problem. In this case, the problem is you have minimum problem statement. The only thing that you see is this particular scenario. So look at it. Try to talk among yourself what you can see from this. Okay, because you need to know that in order to figure out what components will be needed for your scenario. All right, so now it's going to be the thing about observation. Okay, you need to observe this, analyze this, and try to come up with the components that you need for your scenario. And based on that components, then you can start talking among yourself how this should be done. Okay, I can tell you now that the solution is very simple and straightforward. But to get to that simplicity and straightforwardness, you have to try to understand the problem statement first. You have to understand what exactly is given and what will be needed. Okay, so talk among yourself. Try to see what is going on here. All right, and the thing that you probably don't see is when it changes all this color, that's a click. All right, that's a click when it starts changing. Okay, so you see that when this is initially, all right, you start running, the mouse move. Okay, that's the mouse move is create all the moving of the elements in that. Okay, and then after a while, if you go out, stop moving. Okay, go out, stop moving, and then when you alright, say you come in again, and then you click, then stop, and there's a click somewhere. That's a click. Okay, that's the first click, another click, another click, a click, a click. Okay, so every time there's a click, there's a change in the colors and the pattern. All right, and that's about it. So look at this. Try to see what you can observe and figure out the needed elements in your scenario. All right. And I want each group to put your solution, okay, onto the page right here with all the group members' name. All right. So explain why that is your solution. You need to at least talk about the analysis process. Okay, what you get, what are the expected, or at least you assume elements in the scenario. If you want the paper, have them here. Okay, one should be enough. Use it carefully. Oops, sorry, that one. One, two. And one more paper. I need to find out. Just a moment. Who else? One more paper? Anyone else? More paper? Can you see it? Okay, fine. on the paper you are going to submit, one of the writing that I want you to write on is that what did you observe? What did you see? Okay, and why did you see? Why the thing that you saw is important in deciding how you would design your scenario. Okay, that's something you can see there. Say the click change the color, so how you're going to deal with the color, so on and so forth. Okay, so specify what you saw in there based on your observation, and then discuss a little bit why you observe the thing you saw is important in the designing of the scenario. Okay, you have about 5 more minutes to turn in your work, your writing. Make sure you write the names of the group members. Okay, you all submitted. Okay. Now, would you move the chairs back and rearrange it for, well, make it a little nicer. Okay, when you if you already submitted, please move back and arrange the chairs a little bit. Okay, so I think most of you knew that the trick for this scenario is the use of the turn towards method. Okay, so you basically use that. For this one, for this example in particular, the tile. Okay, for this example in particular, the tile has been divided into 4 parts, and each of the parts contain the colors. So basically, you get the buffer, the green foot image, and then you draw a rectangle on each of the image right here. So each of the tile you're gonna have 4 colors. Okay, each of the tile you're gonna have 4 colors, and then you can just random the colors. All right, you can have started with the 4 colors and random the color for each of the rectangles. When you click. Okay, each time you have the mouse click, you random the colors again. Okay, and so you overlap the tiles to create that effect, and then you use the turn towards. So each of the tiles will turn toward the mouse. You click, you rearrange the colors. Okay, that's going to have that kind of effect. Okay, so most of you pretty much done using a tile of 1 color, so you're going to have to play a little differently when you click, because the color you're going to have to take care of the zone and change the colors accordingly. All right, good job. I'll see you Tuesday. Thank you very much.